the function or the curve C has an equation like this. The very first question, we have to determine the first order differentiation or the slope of the curve or the equation, that is dy by dx. So if we differentiate this part, d over dx, as the function is y, that's why dy, and we have to differentiate this function or equation with respect to x because the variables are x. So it will be 3x to the power 4 minus 8x cube minus 3. So it will be 4x cube minus 8 or 3x squared minus 0. So it will be 12x cube minus 24x squared, right? This is very basic differentiation of any equation or any function. Now this is number 1, I mean a of Roman 1, and now we have to do Roman number 2. It will be second order differentiation, so d square y over dx square. So it will be differentiate of the first order differentiation value, so it will be 12.3x square minus 24 times 2x, so it will be 36x square minus 48x, right? So A have done. Now it's time to solve the problem of B. What is the main point of B? We have to verify the equation or the curve equation. C has a stationary point when x is equals to 2. So this is the stationary point where the minimum value of the curve, right? So we have to prove that, or the verification whether the curve C has an equation has a stationary point at x is equals to 2. So at x is equals to 2, the stationary point occurs. So dy over dx, so as well the value of x is 2 over to the power 3 actually minus 24. The value of x is 2 because the stationary point at x equals to 2, so it will be square. So we have got 12 times 8 minus 24 times 4, so 96 minus 96, so it will be 0, right? So we know by the definition of a stationary point, when dy by dx is equals to 0, so it means the stationary point at here, yes, right? So when the first order differentiation or dy by dx is equals to 0 at x equals to 2, so yes, we have got a stationary point here. Now time to solve the problem of C. Determine the nature of stationary point and gives the reason why the stationary point I have got this type nature. Anyway, so number C is the nature of stationary point. So indeed we have to have the value of the second order differentiation, so d square y over dx square is equals to actually 36x squared minus 48x. At what point? Of course x is equals to 2. Now plug in the value here, 36 2 whole square minus 48 times 2, so we have got 144 minus 96, so we have got 48, which is actually greater than 0, as the second order differentiation d square y over dx square, the value is greater than 0. It means that the nature of the stationary point is minimum, right? And it is very important, please note that when the stationary point is minimum, indeed the curve will be look like this one. It means that this is the minimum point, and of course this is the x-axis somewhere. This is an example actually. So this is the minimum point where x is equals to 2 and the minimum point at minimum. Anyways, thank you.